Hi, this is Russ Dollinger from Science Glen. I want to show you an interesting reaction. We're going to take aluminum acetate and rubidium phosphate. We're going to combine them together. What do you think we're going to get? Do you know? Can you see it in your head yet? All right, let's look at the Ionic flashcards. That'll help. And those are doing very well right now on Amazon. We've got 33 reviews and 4.9 stars, and there's a 20% discount on that right now. You might want to look at that. So let's look at these. So let's do these a bit by bit. We have rubidium ion, turn that over, and we have phosphate ion. Got this up and centered there. So now you notice that rubidium loses one electron, the 5s1 electron, to be like krypton, and has a charge of +1 then. Phosphate has got a phosphorus and 4 oxygens in a tetrahedral arrangement have a full charge of -3. Now, you want to get to 0. So +1 and -3 don't add up to 0, though. That adds up to -2. So we got a problem there. We have to solve that. Now, let's look at aluminum acetate in the same way. Okay, aluminum, turn that over, and the acetate. Now, aluminum loses 3 electrons to be like neon. Okay, and acetate is all these different kinds of atoms strung together in 2 different versions. It has an overall charge of -1, and it has this flat circular arrangement. It's called trigonal planar. It has an overall charge of -1. Again, +3, -1 does not add up to 0. So we have to see what to do about this. Some rubidium ions, and we've got some aluminum. Oh, I'm sorry, I want phosphates. Pardon me. So we got a phosphate, and we've got rubidium. Now you notice I've got a minus and I got a plus, and these just snap together, just like that. So now everything balances. I've got 3, so it's Rb3, 1, 2, 3, phosphate. So that now works. In a similar way, if I have aluminum, I've got 3 pluses here. It was +3. And I have acetate, and it's -1. And I need 3 of those. I'll stick those, oops, not there. Stick that on there and there. And now I have aluminum with parentheses, acetate, 3. I've got 3 of these. So let's put that up there so you can see that. So it's aluminum acetate. Now, if you put these together, anything that's got an alkali metal like rubidium is going to come apart and go together and come apart and go together. It dissolves in water. It loves being in the water. So all these are going to come off. All of these rubidiums are floating around, and the phosphate's floating around, and it's going to go together and come apart and go together and come apart. In a similar way, anything that's got an acetate will dissolve in water. Okay, so they're going to go on and come off and go on and come off again. So all these various things are floating around and coming apart and floating around and coming apart. And every now and again, the phosphate is going to combine with the aluminum. And boom, it's going to stick together. Let's see if I can get this to orient a little better. And this one is going to hook on here. And that one's going to hook on, oops, I can get it to hook on. It's going to hook on there. And now I've got aluminum phosphate. Look at that, AlPO₄. Now, there is this term, a solubility product constant that it's called, that determines how something likes to be in water or hates to be in water. Well, aluminum phosphate hates to be in water. It has an incredibly small KSP, or solubility product constant. It just does not like to be in water. Meanwhile, the rubidium will go together with the acetate, and we'll end up with 3 of those. Now we have a balanced equation. We have 1 of these that we get as a product, and we have 3 of the rubidium acetates. And that will be your balanced equation. 3 of these and 1 of those. Now, in practice, there's another kind of, so that's a balanced equation, but there's another kind of an equation, the complete ionic equation. The complete ionic equation talks about which things are actually dissolved in the water and which things come out of the water. Well, this is already a solid. It's coming out of the water, and it's not going to go back in the water. It's it hates being in water. But the rubidium acetates, they'll come apart and go together and come apart and go apart, and they're going to come apart. So in the solution, you're going to end up with 3 rubidium ions and 3 acetate ions. That's the way it's going to be. You'll have 1 of those, 3 of these, and 3 of those. Now, if you notice, we started with rubidium ion. We ended with rubidium ion. We started with acetate. We ended with acetate. Those are spectator ions. They're just looking. They don't do anything. We can ignore them. So there's one final equation that we can consider. It's called the net ionic equation, and it just is talking about the things that make the final solid, which in this case is aluminum phosphate. Let's move these out of the way, and we have the aluminum phosphate. So if we take this apart again, we start with an aluminum, and we start with a phosphate, and those things, when they go together, I get this to go together a little nicer this time. Here we go. We got aluminum phosphate, and it comes out of the solution. So we start with this, we end with this, and that's your net ionic equation. It becomes a solid. The Ionic Disc Model is in production right now. It's going to be available in early May, depending upon production glitches and shipping and so forth. We actually just came up with a new way of doing it that's going to be much more effective. So we have a pre-order discount on it. I already have a lot of them coming in, and I have purchase orders from a number of schools that are already starting to happen. So students find this helps them a lot. They like it. It works. It's very, very effective. I'm certain you'll find it very helpful. Thank you very much. I really enjoy helping you guys. Thank you.